In this video, we are going to present the chain rule, and then we are going to use that chain rule to find derivatives. We're going to find derivatives of the examples that we looked at in our last video. All right, so here is the chain rule. So if y is equal to f of u, and that is a differentiable function of u, and u is some function of x, so it's equal to g of x, and it's a differentiable function of x, then y is this composite function, f of g of x. It's a differentiable function of x, and dy dx can be found by taking the derivative of y with respect to u and then multiplying by the derivative of u with respect to x. Another way to think about that, an equivalent way to think about that, is we can, if we're taking the derivative of this composite function where f is the outside function and g is the inside function, then when we take that derivative, we are going to take the derivative of the outside function but leave the inside function the same, and then we are going to multiply all of that by the derivative of the inside function. Right? So the derivative of a composite function is the derivative of the outside function with the inside left alone. I can't emphasize that enough. With the inside left alone, times, right, so derivative of the outside, times the derivative of the inside. So let's go back to our examples that we looked at last time, and let's find the derivatives here. All right, so here we have x cubed was our outside function, 2x plus 3 is our inside function. So we're going to, if we're going to find the derivative of this composite function, we will take the derivative of the outside function. What's the derivative of x cubed? Well, it is 3x squared, but the inside is 2x plus 3. And then we want to multiply by the derivative of the inside. What's the derivative of 2x plus 3? Well, that is just simply 2 plus 0, or 2. And so we took the derivative of the outside, the inside stayed the same, and then we multiplied by the derivative of the inside. And so let's look at our second example. Here our outside function is 4x to the 6th. When we take our derivative, we will have 24x to the 5th. But the inside is going to be x squared plus 2x minus 2. And then we need to multiply that. We need to multiply that by the derivative of the inside. So what is the derivative of x squared plus x minus 2? Well, that is 2x plus 1. Excellent. All right, let's keep rolling. Next, we have our outside function is sine, and the inside function is 3x minus 1. So if we're taking the derivative of this composite function, we take the derivative of the outside function first. So the derivative of sine is cosine of the stuff on the inside. The inside stays the same. So our inside function was 3x minus 1. And then we are going to multiply that by the derivative of the inside. Multiply that by the 3. By 3, because that's the derivative of 3x minus 1. All right. If we take the derivative of this composite function, where x squared plus 5 is our outside function, and tangent of x is the inside, the derivative of the outside is going to be 2x plus 5. But the x is going to stay the inside function, so the inside function is tangent x. And then we need to multiply that by the derivative of the inside. The derivative of tangent x is secant squared x. And finally, if we were to take our derivative here, our outside function here is cosine x. The derivative of cosine is negative sine. The inside function stays the same, x squared plus 4x plus 7. And then we need to multiply by the derivative of the inside. The derivative of the inside is 2x plus 4. And those are our derivatives using the chain rule. In our next video, we will look at even more examples where we use the chain rule. I will see you there.